Let us do this question. This says a uniform cylinder of mass m and radius r is to be placed over. Let us take this thing. So this is how a step looks like, and this is a step. On this step, this is my step. On this step, the cylinder has to roll. So the force is given in this direction. Force is given in this direction, and mg is acting in this direction. Mg is acting in this direction. So this is my mg and that is my force. Okay. So the axis of rotation is this. About this axis, it is rotating like this so that it can climb over the step. Okay. I hope you understood what is the axis. Okay. So the force, if at all I draw backwards, the line of action, of force is not passing through the axis. That means this force is going to create a torque. How much that would be? So what we will do, we will draw a line from the axis. This is called as the perpendicular distance over to our line of action of force. So the whatever the perpendicular distance that is present is the torque that is caused, the torque that is created by force is equals to F into R or R cross F. Okay, whichever you want to write. R cross F, the perpendicular distance into F. Okay, so mg is also creating a torque. Torque due to mg. So mg is another force. Mg's line of action is in this way. Okay, so mg is also not passing through the axis. So mg is also gonna create a torque. What is the perpendicular distance? The perpendicular distance is this x. This x is the perpendicular distance between the axis to mg. Okay, we should find out how much is that x. So mg into x is my torque due to mg. Torque due to mg. So mg into this x, we'll find out how much is that. This is r and this is also r. This side is also r. Okay. So how much this side would be? This side would be r minus a. So now what we do, x is equals to, the small x is equals to hypotenuse x square plus r minus a whole square is equals to r square. X square is equals to r square minus r minus a whole square. That is my x. So x is equals to how much? Under root of r square minus r minus a whole square. Okay. So this is the torque due to mg. So he says, what is the minimum amount of torque that is required to rotate it over the step? So the minimum amount of torque means this torque and this torque must be equal. Actually, the force, this torque must be a little bit greater than this torque. So the minimum value means they both must be equal because this force is trying to make it go up the step and this mg is trying to make it go backward. So what we do is torque due to F is equals to R cross F. So can I write R cross F is equals to mg into under root of R square minus R minus A whole square. So F is equals to, F should be actually greater than or equal to mg by R into under root of R square minus R minus A whole square. So the answer would be, if I send this mg, this R inside, so how much that would be? He's asking force only. Yes. So if I send this R inside, so F should be greater than or equal to mg into under root of R square minus R minus A whole square upon R square. Because if I send this R inside, that would be square. So R square and R square, that is mg into under root of 1 minus R minus A whole square by R square. So you can say mg into under root of 1 minus R minus A by R ka whole square, because both squares. So 1 minus R minus A by R whole square, the answer would be first option. The first option is your answer for this question. I hope you understood this. If you have any doubt, kindly comment below. Thank you.